Hi, I'm Dr. Trina, and today we're going to talk about the unit circle. Not just a regular circle. We're talking about the unit circle. This one right here. Unit circle. Now, I assume everyone knows what a circle is. If not, it's the round part. And the characteristics of a circle are that from the center of the circle to the outer edge, that distance is known as the radius. It's the same all the way around, hence making it a circle. Now, the unit part is the part that makes it mathematical. Unit in this case meaning one unit of something, be it inches or feet or millimeters or miles, whatever. One unit circle. So why do we need to know about the unit circle? Let me tell you. We are studying the unit circle because the unit circle is the mechanism whereby we get to the part where we can successfully calculate vectors and understand the concept between magnitude or with magnitude and direction combined, which is one of the characteristics, or the two main characteristics, I should say, of vectors. Okay, what's a vector? We're going to get there, but I just told you kind of what it was. Alright, unit circle. Characteristics and mathematical quantities, concepts, etc. that we need to know about the unit circle. Let's get started. Okay, over here I have a unit circle. Over here I have a Cartesian coordinate grid. So Cartesian coordinates are x's and y's. Cartesian coordinates, x, y. Alright, and if it was three-dimensional, we x, y, z. We're only dealing in two-dimensional plane, x and y. Okay, positive. So this is the positive x axis. This is the positive y axis. Where they intersect is at the origin, which means this point has no coordinates. 0, 0. You have not going anywhere this way, that way, up that nowhere. 0, 0. Okay? Now, as we get to a point where you're like, well, I don't see any circle over here. Let me explain to you what this thing is going to do as with respect to this thing. Alright. I'm going to pick a random point on this XY axis grid coordinate thing, as we call it. Cartesian coordinates are these numbers. This is just a plane in two dimensions. So I'm going to make plane PLANE. I'm going to pick a point in the first quadrant. What's a quadrant, you say? Quad meaning four. Quadrants are the equal sections that our XY axis or grid is divided into. Quadrants. Okay? There's a Q1. Looks like a 7. It is not. Alright, we have Q1, where this is quadrant 1. The x component is positive and the y component is positive. So we write quadrant 1 is positive, positive over here. So every value in this direction is positive, every value in this direction is positive. And I have it right here. Quadrant 2 is over here. I'm going to write Q2, and I'll write it here too. Q2 is negative x. Well, since we write it over there, no need to write it over here. Q2 is negative in the x direction and positive in the y direction. So everything in Q2 is going to have negative, positive. So what that means is the x coordinate, whatever these numbers are, let me go back to this one, is going to be a negative x, positive y. Let's look at this point before I do quadrants 3 and 4, so I don't get off track. We picked a point on this grid, random point. Now we can find the coordinates of this point by what we do, which is just count over the units in this case. 1, 2, 2 in the x direction, and then up 1, 2, 2 in the y direction. So what are the Cartesian coordinates for this point? The Cartesian coordinates for this point are 2, comma 2, because we went 2 in the x direction, 2 in the y direction. Alright, so this point has 2 comma 2 as its coordinates. Alright, now we're gonna use this concept with respect to this circle. Now, how are we gonna do that? Because the circle don't have any boxes inside of it to count out any 1s and 2s and 3s and 4s. That's why it's called the unit circle. We need to, and let me draw a box. We're going to get to the level of specificity for the unit circle. This is supposed to be square, but I didn't make it square. I was drawing my lines. But this point in the middle is where we start off right here with our unit circle. So, well, how are we doing that? We're gonna think about it, visualize it, and then make it make sense. Let me finish this quadrant stuff before we get going to the unit circle. So this is our third quadrant, Q3, and we are negative in the x, negative in the y. So this one should have negative and negative. Q4 is this one, positive x and negative y. So we're going to have positive, negative. Note, they should all be different. This one is positive, positive. And my hand and my brain stay in the same place. Positive, positive. Alright, that's Q1. Alright, so if our point, if we're doing a problem, let's say we're doing addition of vectors coming along, ends up over here, your components for whatever that addition, no matter how many vectors it is, its final location lands over here. Your calculation should match up with respect to the sign. The x value, SIGN. The x value should have a positive and the y value should have a positive. Okay. This is our Cartesian system. I'm going to erase this in a second. Now, let's look at our unit circle with respect to this box. Okay, so I'm going to draw the box again. Y'all don't laugh at me in my box. I'm drawing the box. Okay. Box. One side. Two sides. Notice how I'm putting the edge right at the tangent point on the edge of the circle, right? And box. Okay, not bad. So now here we are. We have our unit circle. And we have blown up this thing. This is the equivalent of this. So if we look at this, this counts over 1 in the x direction, no farther than 1. This goes 1. This goes 1. This goes 1. All these points go no farther than 1 in magnitude. So this is like 1, 0. This is like negative 1, 0. This is 0, 1, negative 1, 0, positive 1. Then these on the corners, which don't have anything to do with our unit circle, but I just want to show for clarity that nothing related to these boxes is larger than 1. So this is 1, 1. This is negative 1, 1. Negative 1, negative 1. And 1, negative 1. So everything is length 1. Let me write it underneath. So we're going to use this again. 1 for our unit circle. 1. So when we start talking about the unit circle and vectors, we're going to now introduce some trigonometric functions. The easy ones, cosine and sine and tangent. We're going to use cosine and sine because cosine theta is the equivalent of your x coordinate when you're looking at anything along the unit circle. Sine theta is the equivalent of your y coordinate. So let's look at this circle, for example. Visualize, make it make sense. Visualize and make it make sense. This is our origin. So from here to here is 1 unit. Now we're going to also introduce the concept of degrees, because degrees are measurements based on direction. So let me do a demo real quick. Right now, let's pretend like I'm right here. Alright? I'm going to turn, and now I'm facing this way. I'm going to turn again, facing this way. Turn again, facing this way. Turn again, facing that way. Every time I turned a total distance of 90 degrees, because I went perpendicular to my original position. So right now I'm looking at the camera. This wall right here is 90 degrees from here to here. And then I went from there to there. Then I went there to there. Then I came back around. Okay, so we're going to look at that on this unit circle, right? So this is 0. This is 90. This is 180. I didn't put the X's and the Y's. Alright, so I'm just trying to neaten it up some so the other boxes are not relevant. Alright, this is negative x, negative y, so this is 180 degrees. And this is 270 degrees. And 0 degrees and 360 are the same, because if you note, when I started my rotation, this was 0. But when I went all the way back around, I covered all of these angles to get back to here, and that's how we get to 360. So you start at 0, and doing a 360 means ending up back where you started. So if you say do a 360, that's what you're saying, as opposed to doing a 180, which is in the opposite direction of where you were. Okay, so if somebody went from here to here, they actually did a 180 if they completely flipped on what they said or did. Alright, now unit circle. X right here is our radius is 1, and so from the origin to here we have a distance of 1 unit in the x direction. We have no units in the y direction. So what does that mean? We have a coordinate of 1, 0, right? 1, 0. The x is 1, the y is 0. Now let's go to the trig part I was talking about. Backing up a little bit. When we're not backing up, we're doing an addition to, which is going to make this thing make more sense. I'm going to introduce those trigonometric functions. And I don't believe you need this part anymore. So I'm going to erase it in a second. But before I do that, I'm going to say our x component is calculated by cosine theta equals the adjacent, and I'll show you what that is in a second, side. Is that showing up? Yes, it is. Over the hypotenuse. And as we move forward, I'm going to start abbreviating adjacent and hypotenuse and opposite, okay? So this is the x component. So right here, for example, if we wanted to look at this thing, this is the 0, is at 0 degrees. Basically what that is saying is that the cosine of 0 degrees is the adjacent side, which I will show you, divided by the hypotenuse, which is 1, because the hypotenuse is the longest side of the triangle. And so cosine of 0 is going to end up equaling 1, which is what this thing says it is. 1 is the cosine of theta. And I'm going to prove that to you shortly. So the y component is calculated. Now notice we didn't do any of those calculations up here on this Cartesian grid, because we could just count it out, because we were outside of this little space between 0 and 1. So anything between 0 and 1 is like a half or a fourth or 0.12 or something like that. Boom, we're outside of that. Now mind you, yes, these little boxes, each of them have divisions in between where they could be 1.1, etc. That does not have anything to do with this unit circle right now. Okay? So, y is calculated by the sine of theta, which is equal to the opposite side over the hypotenuse. Now, what's the hypotenuse? You might want to ask yourself if you don't know. We're going to start with Pythagorean theorem. And the Pythagorean theorem is about right triangles. Okay? So, we're going to draw a right triangle. We're going to attempt to draw a right triangle. Alright, let's see if we can get this thing done. We can't. Let me try it one more time. I'm trying to make it straight. Boom. Okay. Close enough. So the Pythagorean theorem, this is our right angle. Right angle is 90 degrees, if you did not know. I'm going to write it here. $90. And since a triangle cannot have more than 180 degrees, it's got two angles left, and one of them is 90, which is half of the total amount of angles that a triangle can have. Then this angle is opposite the largest or longest side. Okay? So the right angle is opposite the hypotenuse. Alright? Now is the part where I start abbreviating HYP. Okay? So now, what did I say? X component is calculated by cosine theta. Where's our theta? Theta is right here, which is our angle. Okay? So, this is going to be our X component. Guess what? It's along the X axis. This is going to be our Y component. Guess what? It's along the Y axis. What we're going to do, because I haven't written the theorem down yet, we're going to call X A. We're going to call Y B. That's all we're doing, is calling it something other than X and Y. And a hypotenuse is going to be called C. Pythagorean theorem states, let's draw an arrow, C squared equals A squared plus B squared. Now let's think about that for a minute as it relates to our unit circle. If we look at our unit circle, I'm going to draw a random right triangle here so that we can get some context from over here to over here. Alright? Random line. Now, it's still equal to 1 because it's going from the center to the edge of the circle. Recall I said any line from the origin to the edge had a measurement of 1. So the radius of this circle is 1. All the way around. So I draw this random line which has theta. I'm going to erase this 1 because we're not using this 1 right now. Okay. Now, How do we determine what x and y are, and how do we get this right angle? We basically just draw a line from here down to the x-axis, and there's our right angle. So this now becomes A, and this becomes B. Now you're asking yourself, how is that A and B, and how do you know? Well, I'll tell you how I know. Because the Pythagorean theorem tells me so, based on what c squared is, and if we know our angle, we can find A and B. Because this is basically going to give you A, and this is going to give you B. Because those are the x components, and that's the x and that's the y component. So, if you think about this radius as moving that way, as it moves, the x component gets smaller and the y component gets larger. It doesn't do it immediately, but it does it incrementally as you pass along this arc. And then you continue around the rest of the circle. So right here we said 1, 0. 1 was the x component, 0 was the y component. As we start going this way, the 1 gets smaller and the 0 gets larger, but they still must satisfy this equation. So let's look at an angle, and we're going to use our calculators to do this thing, but we're going to also put we're going to use Pythagorean theorem to prove that we do get 1 for our c squared, because 1 is the value of our hypotenuse, right? So 1 equals c all the time for the unit circle. Okay, so we're going to have 1 equals, we didn't pick an angle yet. This one hasn't quite hit the halfway point, which would be 45. So let's make up something. Let's call it 38 degrees. Because it's not quite at 45, but it's close. Okay? So now we're going to look at this to calculate what A and B are, because we don't have any other information other than the angle and the hypotenuse, right? I'm going to let you think about that for a minute. Okay, so there's a lot of stuff going on here on the board. We have our hypotenuse, we have our 38 degrees, we have A and B that we need to calculate. We are looking at just this portion of this grid on this Cartesian coordinate axis. Grid. XY plane, whatever you want to call it. Okay? So we are all up in this region. None of the other stuff matters. Okay? At this point, nothing over here matters other than what's inside this box. Okay. So we have, I'm going to erase this 1 because it's looking out of place right now. We have c squared equals a squared plus b squared. Let's find out what this thing is first. These cosine things. How do we get our a squared plus b squared? We said the cosine of theta, and in this case is 38 degrees, equals adjacent side. Adjacent means attached to or next to. So that's A over hypotenuse, 1, right? So in this case, our cosine of 38 is actually the length of this side, okay? So whatever the length, whatever our units are, this portion is going to be that length, all right? So sine of, let's do cosine first. Now, calculator is what I'm going to use. I have a book where they were all calculated some hundreds of thousands of years ago. I don't know how long ago, I forgot. But all of these were done by hand. They didn't have any of this stuff. Somebody calculated every cosine and sine on a table. That's pretty cool. There's probably a lot of measuring and stuff going on. So to use your calculator function, the one I'm using on my iPhone is called calculator. I think that's it. I type in 38, then I hit the cosine button, and it says cosine 38, and I hit equals. And there is the cosine of 38. 0.788. I'm not going to use all of the coordinates. I'm not using all of those digits after 0.78801. Alright? Equals 0.78801. Now what's going to happen is our numbers are supposed to add up to 1 when we do c squared equals a squared plus b squared, because the hypotenuse is 1. What we're going to end up with is something close to 1, but not more than 1, because we rounded off. Now I'm going to do sine of 38. Same way. 38 goes in. Hit the sine button. Sine of 38 equals. There it is. Now we have 0.61. We have 61566. Now are we done? Technically we are done if we were just asked to find the values of a and b. But what we are going to do is to check them to make sure that they satisfy the Pythagorean theorem. Okay? So the Pythagorean theorem, so this is A and this is B. Because we cross multiplied the 1 over. So that we just had A equals that. And I didn't write B over here. B over 1. Write B over 1. B equals 0.61566. I think. So now, let's check that. (61566). Okay. We're going to do c squared equals a squared plus b squared. C squared equals a squared plus b squared. And in this case, c squared is 1. 1 squared is 1. Now we're going to square this and see if we get 1. Alright, 0.78801 squared plus 0.61566 squared. Now we square them both and add them up and see if they come up to be 1. Now, this is the first one. This is the last one, actually. This is the sine values that I got for sine of 38. I'm going to take the lazy route and just square all of them. That'll also make our value more accurate. So I squared it. Equals this. 0.3790 blah blah blah. So now I'm going to add this thing squared. 0.78801. So I need some parentheses. 0.78801. So now I'm going to square that inside the parentheses. Squared. Squared. Now you see where the gray parentheses on the outside is. I'm going to close that up. There we have it. Now I can say equals. Look at that. Look at that. Look how close to 1 it is. So we got, if we hadn't rounded this one off, we would have gotten even closer, maybe gotten to 1. Alright, point. We should have gotten to 1. 9, 9, 9, 9. We got 5 9s and 2 8s. Hot diggity. Alright, we're going to put it there. So, we got the problem right. Okay? So, to recap what just happened, we started out over here in the XY plane. We talked about quadrants 1, 2, 3, and 4. And we talked about the unit circle and how everything relevant to what we're covering is inside these 1, 1, 1, 0 boxes around the origin, which is what these represent. Okay? Now, mind you, the circle doesn't touch any of this space over here. These things out here have their own values. Like this corner right here is 1, 1. 1, 1 does not satisfy the Pythagorean theorem. Okay? Neither does this one. 1 minus 1. If we put those values in, we're not going to get 1 squared equals, we're going to get 1 equals 2. And that is not the right answer. Everything that we do inside of this space is going to satisfy the Pythagorean theorem because we will will it to be so. Plus, the fact that we need to know directions, we don't necessarily need to know locations. We need to know directions, which is what this thing is giving us. Okay? There was one more thing I was about to mention. C squared, Pythagorean theorem. We started out over here. Cartesian coordinates. Cosines and sines. The ones and the minus ones, etc. and so forth. It'll come back to me. Alright. The Pythagorean theorem, which is our friend. Very much so. What was the thing? I'm not sure what the thing was, but it will come back to me and you'll probably say, oh yeah, that makes sense, Dr. Coleman. I thought of it myself. Okay, so I'm going to shut it down right here. And I hope that this was useful information to you. What we're going to do next time is work out some of these in real life examples and work on the concept of getting the x and the y coordinates for a vector in general. Okay? And I hope you found this enjoyable, like I said. And until next time, I'm Dr. Coleman.